So looking at number 13, for this one, there's no real advantage between choosing one side versus the other. I'm going to pick to start on this side, though. There's really no advantage to doing that. It's fine to do either side. If I look at secant squared, and I go to my list of properties, I have 1 plus tan squared as one of the options. I knew that I wanted to choose that particular property because when I looked at the left-hand side, the only operation or the only trig function on there was tangents. So I wanted to rewrite secant in a way that got the right-hand side to only have tangents in it. Everybody okay with that idea? Okay. So if I look at this carefully, this looks a lot like a quadratic equation now, where if I just say y is the same thing as tan x, I have 1 minus 2y equals, or plus y squared. That factors to 1 minus y, 1 minus y. And in our case, y is tangent x. And since there's 2 of those 1 minus y, we have 1 minus tan x squared. And we're done with this one. 17 is cosine squared x minus 1 over cosine x equals negative tan x sine x. So it doesn't really matter which side you start on here. Again, I don't think one side is more beneficial to start on than the other. For the sake of argument, I'm just going to start on this side. I'm going to start by rewriting tangent as in terms of sines and cosines. And when I multiply those two things together, when we multiply fractions, we multiply the tops together and the bottoms together. And then I recognize that on my identity sheet, one of my derived identities is sine squared equals 1 minus cosine squared. And when I distribute that negative 1 through, I get cosine squared now becomes positive, 1 becomes negative, and that is exactly what the right-hand or left-hand side was. 21, this is just going to be irritating. That's okay, though. We have cosine x minus sine x squared plus cosine x plus sine x squared is equal to 2. So I'm going to start by foiling each of these out. I'm going to skip writing down the foiling step, though, because it's so much writing. Is everybody okay with what I'm about to do? Are we sure? Okay. So I'm going to get cosine squared minus 2 cosine x sine x plus sine squared from the first one. And then from the second one, I'm going to get cosine squared plus 2 cosine x sine x plus sine squared. And now I'll notice if I try to combine like terms, I have a negative 2 cosine sine x and a positive 2 cosine sine x. So those can cancel out. And what I'm left with then is cosine squared plus sine squared. That's 1. And then another cosine squared plus sine squared. So that's 1. And then I have 1 plus 1 is 2. Have to do what? No, that's just I'm done symbol. If you didn't include it, it's not incorrect. 25. So here again, each left-hand side, right-hand side are about as equal in difficulty. For the sake of argument, I'm just going to start with the right-hand side. And my goal here is I'm going to look at and try to come up with a way to turn 1 minus sine x in terms of cosines. So the way that I'm going to do that is I'm going to multiply the top and the bottom by 1 plus sine x. Hi. Yeah.
Gotta make sure this is the proper cool.
Selena, you have a get out of jail free card. Yeah, you have 10 minutes to get through, and then your weekend starts early.
I'll miss you, Mr. Ford.
I'll miss you too. Good luck delivering notes. So I'll FOIL out the numerator. When I do that, I get 1 minus sine squared. And the denominator I'm not going to multiply out. I'm just going to write them next to each other like a multiplication problem. Now let's look at the advantage of what happened here. So the key was I got this 1 minus sine squared, and I wanted that because it turns into cosine squared. And now I can reduce. And that's what I was searching for. What number are we on to now? 29? Yeah, of course you can. So that's going to be cotangent squared x minus cosine squared x equals cosine squared x times cotangent squared x. So I guess if I look at this, I'm probably more interested in working on this side. So I'm going to start by writing everything in terms of sines and cosines. And what I'm going to do is just make a common denominator for these things. So I'll multiply the top and bottom of this by sine squared. That's going to give me cosine squared minus cosine squared sine squared all over sine squared. Now what I'm going to do is look at the numerator. So I notice in the numerator I have a, oh, man, that would have been easier. I'll point it out in a second. I just made a common denominator, so I could subtract the two fractions. If you do it to the top and the bottom of a fraction, yes. Right, just remember like when we added like 1/2 plus 1/3, we did the same kind of thing. Where we'd multiply the top and bottom by the same thing, and you can do that to add fractions. So that's the idea what I'm doing here with the sine squared, is so that I'd have a common denominator for these two things. So if I do this now, I notice that if I say this is the same thing as cosine squared over sine squared times 1 minus sine squared. And cosine squared over sine squared is cotangent squared. And 1 minus sine squared is cosine squared. And that's what I was looking for. And you heard me remark earlier that, like, oh, I should have done that. So what I'm going to do is just go back to the beginning and show you what I noticed that I could have done that might have made my life a little bit easier. So at this step, what if I factored out the cosine squared immediately? I'd have this, right? Everybody's okay there? 1 over sine squared is cosecant squared. And cosecant squared minus 1 is cotangent squared. And I'm done. That's why I was like, oh man, I did not do the fastest way possible there. But it still worked, right? So it doesn't matter if you don't do it the fastest way possible. You can take 47 steps and go around in a bunch of circles, but if you're doing all correct things and not making up any math of your own, it's okay as long as you end up with the right thing at the end. Gabrielle. Oh, sure. What number are we on to now? 33, right? Okay. You can rearrange them. Yep, you can, and feel free to do that. Yep, you can absolutely use them that way. What's up, Gabby? Okay. 33. So this is x sine alpha plus y cosine alpha squared plus x sine alpha minus y cosine alpha equals x squared plus y squared. This is almost the same problem as number 21. So I'm going to do it the same way. So I'm just going to start by foiling these two out. When I do that, I get x squared sine squared alpha plus 2xy sine alpha cosine alpha plus y squared cosine squared alpha plus x squared sine squared alpha. And then I'm going to go down to the next line. 2y sine alpha cosine alpha plus y squared cosine squared alpha. So I just ran over into the next line because I had too much going on. Ooh, whoa. Yeah, I copied this down wrong. Yeah, so it's not a tremendously big deal, but it's a medium big deal. So this one should be oops, not that one. No, that's not the one I want to change. Jeepers creepers, guys. It gets confusing. Yes. Okay. Sorry about that. It was an easy fix, though, right? 2 little things to erase. All right. Now what I'm going to do is look for like terms to combine. Whammo, whammo. So if I look here, I have a x squared sine squared alpha and an x squared cosine squared alpha. If I take those together, I can factor out the x squareds. And similarly, I can take the y squared cosine squared and y squared sine squared. Oops. And what is sine squared plus cosine squared? 1. So I'm left with just x squared plus y squared. On to 37. This looks horrible, right? I don't see any obvious place to start. So you say you want to start over here? Sure, let's give it a shot. So I suppose what I would do is I'm going to start by, go ahead, Selena. I'm going to rewrite 2 sine squared as sine squared plus sine squared. And I am going to notice that I can take one of these sine squareds, and I'm going to rewrite that as 1 minus cosine squared. Yes, Megan. You could. Yep. It doesn't matter, because what's going to happen is you're going to end up with sine squared minus cosine squared on the next line anyways, right? So that's perfectly fine to do also. Oops, there's a 2 there. Not sure what to do with that yet. So I notice that these negatives will cancel out. Oh, I remember what to do with this now. Hey! Hey! My eraser wasn't working. It's still not working right. I know, it's what a jerk. Okay. So, are you ready for some trickiness? You're not going to like it. Ready, get set. Here we go. I'm going to take 1, and I'm going to rewrite that as sine squared plus cosine squared. I rewrote 1 as sine squared plus cosine squared. So I took this 1 right here and turned it into that. Now you should look at me and go, why in God's name would you want to take it and make it more complicated? It's a perfectly valid question to ask. If I look at that denominator now, though, this looks a lot like x squared plus 2xy plus y squared, where x is sine x and y is cosine x. You agree with that? That's factorable. It factors to sine x plus. Oh, well, this is like my x squared, y squared, 2xy. So I just rearranged it. Is that okay there? Okay. So yeah, sorry for I got going fast. I should have written that step. If I check out the numerator here on this step, this also is something factorable. This is a difference of two squares, right? So I can say sine x plus cosine x times sine x minus cosine x. And those things cancel, and now I have exactly what I need. This is harder than one that I would expect you to be able to do on your own. So I think this would be too difficult for a for a quiz or a test in class. That was a doozy there. What's next? 41 is the next one. Thank you. Okay. I think I want to work on this side. And I'm going to start just by rewriting cosine to the third as cosine squared, and then times cosine. And the reason I did that is just because now I have that cosine part taken care of. So whatever else I change, that cosine part I'm going to leave alone. And if I look at this side, everything in here is in terms of sines. So I'm going to start by writing that cosine squared in terms of sines. How can I do that? 1 minus sine squared. Everybody's okay there? Distribute. So that's sine to the squared minus sine to the fourth cosine x, and that's what I was fishing for. Ethan, you may. Yes, sir. 45. It's tan x over 1 minus cotangent x plus cotangent x over 1 minus tan x equals 1 plus secant x cosecant x. Oh, this looks horrible. Yeah, it does look like something to make you want to cry. I guess I'd start on this one.
I cried on the outside for them. They were real to me.
Okay, so I'm going to start by just making common denominators. Yes, Gabby? Oh, I haven't gotten through to see how horrible this is yet. Something wonderful might happen halfway through, and it could turn into something really easy. So I'm gonna decide not to answer that question until we get to the end, to just see how terrible this turns out to be. But it seems like this might be biting off more than what's realistic for you guys to chew. So let's multiply these out now that we're making common denominators. So the top, when I multiply tangent times 1, I get tangent squared. And then tangent times tangent is tangent squared. And then do the same thing here. So I have cotangent times 1 is cotangent. And cotangent times cotangent is cotangent squared. Oh, thank you. That would have been a nightmare. And then let's FOIL this thing out. So I get 1. And then I get a minus tan x. And then I get a minus cotangent x. And then I get a positive tan x cotangent x. Everybody agree with that? All right. Where am I trying to get to? Whoa, jeepers creepers. Okay, so let's see here. Oh, tangent times cotangent. What's that? That's 1. Everybody agree with that? Tangent times cotangent is 1. So my numerator then becomes 2 minus tan x minus cotangent x. And then I have up here, let's see, is there something I want to do here? What are my options for those tan squares and cotangent squares? Is there anything good I can do there? Tangent squares both give me secants and cosecants. I don't know. My answer has secants and cosecants in it. Maybe let's give it a shot, see how that does for me. So tangent squared is the same thing as secant squared minus 1. And cotangent squared is the same thing as cosecant squared minus 1. Yes? Because I have a plus 1 and a plus 1. Is that okay? Okay. And we'll distribute these negative signs through. And my numerator I have tan x minus secant squared x plus cotangent x minus cosecant squared x. And then I have a plus 1 and another plus 1, so I'll put the 2 there. This is not looking good, guys. I don't like at all what I've done so far. This is all terrible looking. You may. So I'm going to just start over. I don't like the way that's going. So my new tact is instead I'm going to put everything in terms of sines and cosines as my first step. So there's nothing wrong with doing this. It happens to the best of us. I'm sure I could have muddled my way to the finish, but it was getting terrible, and I just said to myself, you know what? This thing is not getting any simpler the way that I'm doing it. In fact, in some ways, I'm making it worse. So let me go back and try something different. So I've gone back and just rewritten everything in terms of sines and cosines. And I see let's try doing this instead. So I'm going to multiply the top and bottom of this by sine x cosine x over 1. And the same thing here. Maybe that'll be easier. So when I multiply to the numerator, the cosines cancel, and I'm left with sine squared. When I multiply to the denominator, I have sine x cosine x. I multiply here, the sines cancel, and I have minus cosine squared. I do the same thing here. Sines cancel, so I have cosine squared. I multiply here, I have sine x cosine x. And I multiply here, the cosines cancel, and I have I have minus sine squared. Okay. So I guess in the denominator, I can factor off a cosine here. And on this one, I can factor off a sine x. Okay. Still not really helping me much, so I guess it's time to make that common denominator. I've been avoiding doing it, hoping for something good to happen, but I don't see anything good. So I'm going to do this one by sine x over sine x, and this one by negative cosine x over negative cosine x. Oh, jeepers creepers. Who are my Algebra 3 4-stars? Anybody an all-star from that class? Do you recognize this thing? That is a difference of cubes. Now the better question is, do you remember the factoring pattern for the difference of cubes?
Absolutely not.
That's the factoring pattern. Yeah. This is, to answer Gabby's question from before, way harder than what would be realistic for me to expect you to do on a test setting. No way that's realistic. But I see a bunch of good things starting to happen now, as we've finally gotten to a place where, thank goodness, life is going to get easier for us. So I see a couple of things right now that are really lovely going on. Notice that these things can cancel. Everybody agree with that? Notice in this parenthesis here, I have sine squared plus cosine squared, right? So I'm going to be 1 there. So now I have 1 plus sine x cosine x over sine x cosine x. And here we go. Finish line is now in sight. I see it. So now I'm going to write these as 2 separate fractions. So if I think about this first one as 1 over sine x times 1 over cosine x. There's my answer. TGIF. That was horrible. Way beyond the scope of something I'd expect you guys to be able to reproduce in a test setting. Yeah, that was a doozy, guys. And then the last one is 49, correct? This one is very easy, yeah. So I would just start on this side. 1 minus sine squared is cosine squared. And cosine squared times cosine is cosine cubed. Done. Yeah.
Why did they go from like one of the hardest? Yeah, it goes from really hard to like
Yeah, I don't know why they picked this particular order for things. But here's the thing, is that like 41 through 44 are also very, very easy. And then 45 through 48 are all terrible. And then 49 through 51 are very easy again. I don't know their reasoning.
Here's a sample for that one, like hell, but then here's like the good side.
So here's what we have coming up. Is I'd like to do a test on this 5152 stuff. Here's what I want to do with it though. I'd like to do it on Tuesday, but I'd like for you guys to be able to use your homeworks that you've done for 5.1 and 5.2. You can look at those while you take the test. Does that seem more realistic to be able to do this in Tuesday if you're able to look at this work that you've already done? You will also get the sheet of identities. I will give you that. And I'll give you your homeworks that you've worked. You don't have homework to do this weekend. And as a result of me wanting you to use your 5.1 and 5.2 homeworks for the test, I don't want to take them from you now. So, what I feel uncertain about my ability to get it done and handed back to you on Monday. So, I'll just collect everything on Tuesday. You'll turn in your homeworks when you turn in the test. And my idea here for it is I'll do, like you'll have, I would say I'll give you like 5 simplify, 5 verify, but you only have to do 3 from each section. So you'll have some choice if you get to one that you're like, I just can't figure out what to do with this. You can quit and go to a different one.
Oh, you're still recording.